Hi, this info session is part of a wider user uptake strategy of the European Commission. One of the aims of that strategy is to stimulate the development and use of innovative downstream applications that incorporate Copernicus data and services. The growing renewable energy sector is best placed to use new technologies and to benefit from Copernicus products and services that offer full, free and open data. These data are currently supplied by 6 Copernicus services dedicated to the atmosphere, to the climate, marine, land, emergency and security domains. In this module, I will show you how to estimate annual forest biomass production with Sentinel imagery and derived products provided by the Copernicus Land Monitoring Service, CLMS. Woody biomass produced by forest areas is abundant on Earth and can be used as a fossil fuel substitute. However, to use woody biomass efficiently as a renewable energy source, we need to quantify it, to map it, and to monitor it. Traditionally, allometry measurements and equations are used to determine the annual production of biomass by a forest stand. But this technique is time-consuming, costly, and limited to small areas. In addition, biomass and carbon stocks estimated from forest inventory data have usually some spatial and temporal gaps. These data gaps can be easily filled with aerial photographs and satellite imagery. In parallel to these traditional methods, remote sensing techniques have been developed. In particular, Sentinel images, in combination with the Copernicus Global Land Cover products and meteorological information, can be used in a cost-effective way to estimate the biomass energy potential of a large region and for different land cover classes, for example forest, grasslands, and rangelands or tropical savanna. Remote sensing data are acquired by airborne campaigns or by instruments on board satellites. These data are available at different scales, from local to global and from various sources including optical, radar and light detection and ranging sensors, LiDAR. Optical remote sensing data such as spot vegetation, ProBavi, Sentinel-2 and Sentinel-3 images allow to generate vegetation indices that are useful in biomass estimation, like the leaf area index, the fraction of absorbed photosynthetically active radiation, the normalized difference vegetation index, and the dry matter productivity. Currently, the Copernicus Global Land Service provides a suite of vegetation indices that can be used to estimate total forest biomass production on an annual basis. In this session, I will focus on the normalized difference vegetation index, NDVI, and on the dry matter productivity products, both at 1 km resolution derived from the ProBavi sensor. First of all, a short introduction to the above-ground live dry biomass. The biomass of the tree refers to the weight of mass of its living plant tissue and is generally expressed in metric tons. Live biomass can be separated into above-ground leaves, branches and stems, and below-ground components such as roots. It is most common to estimate the above-ground live biomass on a tree, which is the weight of the living above-ground plant tissue after all the water has been removed. What does the dry matter productivity represent and how to estimate it? The DMP is the overall growth rate or dry biomass increase of the above-ground vegetation. The DMP is expressed in kilograms of dry matter per hectare and per day. The DMP product of the Global Land Service is currently computed with a specific variant equation. For details, please refer to the equation and the table on this slide. What are the Copernicus input data needed to estimate DMP on a forest stand? I remind here the shortened expression of the Monteith equation. The dry matter productivity is equal to the product of the FAPAR index by the maximum DMP. FAPAR quantifies the fraction of the solar radiation absorbed by live leaves for the photosynthesis activity. FAPAR is provided by the Copernicus Global Land Service. DMP max represents the climatic maximum reachable DMP for the virtual cases where FAPAR would be equal to 1. The total shortwave incoming radiation needed is procured by the Copernicus Atmosphere Monitoring Service (CAMS) and is used by the Copernicus Land Monitoring Service (CLMS) to estimate this DMP max. Minimum and maximum temperatures are procured by a meteorological provider. So, we see that DMP can be estimated with remote sensing data and meteorological data information. Actually, the dry matter productivity provided by CLMS is derived from a ProBavi 10 daily synthesis data. The product is calculated globally on a 10 daily basis and made available to the users in near real time every 10 days. Here, the figure summarizes the process flow to produce the 10 days DMP as made available by CLMS. Based on meteo data, a daily DMP max is estimated. At the end of each 10 days, a mean value composite of these DMP max images is calculated. At the same time, the FAPAR product is generated, and the final DMP10 product is retrieved by the simple multiplications of the latter two images. For your information, I present briefly here the range of physical DMP values and the scaling factors. For further details, please consult the product user manual available under this link. I will present you now a series of short videos to support your first steps to download and explore Copernicus DMP data. Let's start with the first one to get familiar with CLMS and global products. First, go to the Copernicus Land Monitoring Service, then go to the global part of the service. The global CLMS proposes 3 domains of applications for vegetation, water and energy. In our case, we're going to select vegetation. The service offers different vegetation indices like the LAI, the FAPAR, the NDVI and the DMP. We're going to select the DMP. Under the DMP characteristics, go to Documents and select the Product User Manual. Click on it, consult or download it. Now, this second video gives you some guidance to register to the Copernicus Global Land Service. On the Global CLMS webpage, select the Vegetation application, go to DMP Index page, select Product Portal ProBavi from June 2014 until now, register on the Copernicus Global Land Service. See on the upper right button. Fill the mandatory fields and save your login and password. Now, this third video introduces you to interesting tutorials prepared by the CLMS service. Go to the DMP Index page and log in. Click on Watch our video tutorials in orange. Then watch instruction movies. Have a look on the other chapters of this online user guide, for example, ordering and subscriptions, troubleshooting or contact. Now I will introduce you to the selection and ordering of 3 DMP summer seasons. Go to the Global Land Catalog of the Copernicus Land Monitoring Service. Log in to the Copernicus Global Land Service on the upper right. Zoom in or out, select an area of interest and enter the name of your area of interest if need be. For example, the country name, here we're going to choose Lithuania. On the right panel, the collection item displays the DMP V1 product. On the right panel, under the basic item, introduce the dates of your temporal series, or better, the recurrent slot you want to get for each year. In this case, 3 consecutive growing seasons. Let's say from June to September and from 2014 to 2016. You get the list of the 36 available products. 3 DMP10 products per month over 4 months for each of the 3 years. Have a look on the name of the product. The start date of the 10 days is included in the name of the product. Quick looks are available as well, and the detail of the product. To show them, click on the correspondent map or on the eye icon. Select all the products and prepare your custom order. Once the ordered data are made available, you can download them. Look at this fourth video. Look at the delivery email informing that the products are available. Then go to the FTP site of the provider with FileZilla. Please follow the FTP link given in the email. Enter your login and password of the Copernicus Global Land Service and drag and drop your package. And finally, I will show you how to explore the Copernicus DMP data in the ESA time series viewer. Go to the ESA ProBath emission exploitation platform. The time series viewer is available there. I draw your attention to the online user guide. Click on Launch Application. Look at the list of the data that you can visualize. Amongst other, the DMP and ProBaV and DVI. Rainfall data are available for some countries, which can be interesting to examine together with the evolution of DMP over the growing season. Click on the chart icon and on the global map icon. Uploading of charts and data for Madagascar Island, which is selected. Change the country, in our case Lithuania, and observe the update of the charts to Lithuania. We have the DMP and the NDVI. Change the length of the time series. Look at the charts per region and at the possibility to get the DMP 10 value of each 10 days represented on the charts. Look at the regional monthly map of DMP for 2016. And then go back to the charts and open it in the left panel of the scrolling down list for the land cover. You can display the DMP time series for each land cover. Click on a chart to enlarge it if you need. Then you can compare, for example, DMP max values of several land cover classes. Finally, you have different means to save these charts. Now, I would like to propose possible post-processing operations. You might need to monitor the evolution of the DMP and the growth rate during the growing season. This could be easily done by differentiating consecutive DMP maps in one season, either in absolute values or percentages. Differentiating DMP maps of the current year and with maps of previous years allows the detection of anomalies in vegetation growth, which can be combined with rainfall and temperature data. Also, cumulating DMP over time from the start of the season onwards provide estimates of final dry matter production for the period. A last suggestion is the computation of DMP values per administrative unit and per land cover class that further enhances the product for the purpose of DMP monitoring at a regional level and for a specific vegetation classes. Thank you for watching this video and I hope it helps.